Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of ECE of RMD Engineering College. In today's session of Analog Electronics, we are just going to discuss about the basics of feedback amplifier. Right. So we know that in most of our feedback techniques, okay, that is in most of our electronic circuits, we will be making use of the feedback. So we could not imagine a single electronic circuit without any form of feedback. So feedback is nothing but a part of the output is fed back as an input, right? So we'll be considering two inputs to the amplifier. One is the actual input, the other one is part of the output which is fed back. So depending upon the phase existing between in the already existing input and this feedback signal, we can categorize the feedback as two types. One is positive feedback or regenerative feedback. The other one is negative feedback or degenerative feedback. From the name itself, we could infer regenerative in the sense the feedback signal will be keep on increasing the already existing input signal. That is, the input signal and the part of the output signal will remain in phase with each other. If it is going to be out of phase, then obviously for the amplifier, the difference of this, that is the input which will be lesser than that of the actual input alone will be getting into an amplifier. Therefore, the gain will be reduced and the consecutive components will get reduced, and thereby it leads to negative feedback or degenerative feedback. Right. So because of this negative feedback, okay, we are going to achieve certain goals. The first one is desensitize the gain. So as mentioned already, the value of the gain will be very less sensitive to the variations in circuit components. That is with respect to temperature. The next one, it reduces the non-linear distortion. Next one, it reduces the noise effect and also have a proper control over the input as well as the output resistance. And moreover, it will extend the bandwidth of the amplifier. But all these properties can be achieved only by sparing or only by expanding some reduction in the gain. So, but this would be a very good trade-off when considering the other desirable properties. This is going to be the block diagram of feedback amplifier, right? Actually, this is an amplifier, okay? So basic amplifier. Here we will be considering forward transfer gain A. Okay, let it be a gentle notation A. And this is going to be the feedback network, or you can say reverse transmission factor beta. Here the signal source, comparator or mixture network, followed by sampling network, right? The signal source may be either a voltage source or it can be a current source. This comparator just mix the already existing input signal and the feedback signal. If both are in phase, it leads to positive feedback. If both are out of phase, it leads to negative feedback, right? The sampling network is used to choose the sample that is going to be fed back as the input through the feedback network, and this is going to be the load resistor. So actually the feedback amplifier is nothing but combination of sampling network, feedback network and mixer network. So as I told you, the voltage source, sorry, the signal source can be a voltage source with a series resistance, or it might be a current source with the shunt resistance. The feedback network, we are told the reverse transmission ratio or feedback factor is beta, that is equal to xf by x0. Always the beta lies in between zeros and 1. So depending upon the type of connection or the attribute, output attribute, you can have the sampling as two categories. One is voltage sampling or node sampling. The other one is going to be current sampling or loop sampling. So voltage or node, in the sense here we could see a parallel connection of the sampling network and the feedback network, or in simple we can say if the feedback element and this output element are going to be connected in parallel, okay, then we can understand that the output is going to be voltage. That is, we have connected it in the shunt form. If suppose the sampler is connected in series, that is if it is connecting the basic amplifier and the feedback network with the chain like structure, then that we can understood that the output is going to be a current, and therefore the current sampler, the feedback signal we will be getting as a current component. Depending upon the mixing, that is how the input and the already existing input and the feedback signal is going to get into the basic amplifier. If these things are connected in chain like structure, then that is called series mixing. Obviously we will be getting a voltage source with the series resistance. If suppose this mixer, this feedback, amplifier, everything are connected in shunt, it means that we are having a Norton equivalent circuit, that is a current source with a parallel resistance. So hope you understand this sessions. We will meet you on another session of classification of feedback amplifier.